Today, we're going to look at different ways we can put functions together and how we can put one inside of another. So we're going to be talking about combinations of functions and composite functions. But first, we need to start by talking about what is a function's domain and how do we find it. Okay, so let me read this to you in math speak, then I'll translate. So if a function does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. Exclude from a function's domain real numbers that cause division by zero, real numbers that result in a square root of a negative number. So division by zero and square root of a negative number. These are things that you can't do with real numbers. So what we're saying here is that the domain of a function is everywhere that doesn't have one of these problems. Okay? All real numbers that do not do one of these two things. So that's the key. That's how we translate this. So take a look at this. I see that this is a rational function. That means there is a letter inside of, in the denominator. And so I know that there's a possibility, in this case of my dividing by 0. I'm going to go ahead and factor the denominator. X squared minus 49 factors to x plus 7, x minus 7. Now, I ask you, what two x values can x not be? Well, it can't be negative 7, and it can't be positive 7, because in both of those cases, it makes the denominator of the fraction 0. Now, there are two different ways that we're going to write our domains. One is going to be like this: x does not equal negative 7, comma 7, because what that means is it can equal anything except negative 7 and 7. Or we'll write it in interval notation. Now, note that my math lab will tell you which way they want it. Okay, so if I ask for the domain in interval notation, well, it's going to be negative infinity to negative 7. So everything up to negative 7, everything between negative 7 and 7, and everything after 7. So not negative 7 and not positive 7. Now, because I have multiple intervals, I need to go back and add what's called a union symbol in between them. So this is a key thing, okay? If you aren't sure how to write it, remember that if you look at a number line and you were to plot x could not be negative 7 with an open circle, and x cannot be 7 with an open circle, but it can be everywhere else, you'll see we have 3 intervals. Now, one of the really nice things about this bit with functions is that if we add, subtract, multiply, or divide them, they do really normal things. Okay, so let f and g be two functions, so they pass the vertical line test. The sum f plus g, the difference f minus g, and the product f times g, and the quotient f over g are functions whose domains are the set of all real numbers common to the domains f and g. Okay, so don't know why that first one showed up early, but there we go. This should be a time symbol right here. Okay, so f plus g of x, when you see that, you can write f of x plus g of x. F minus g of x, you can write f of x minus g of x. So it's almost like you're distributing the x, except it doesn't quite work that way. But this is just a simpler way to write it, because I could say, f plus gh of x, okay, or of 3 even. And I'm going to say I'm plugging 3 into f plus g of h. That's going to be a little simpler than writing f of 3 plus g of 3 times h of 3. So it's a shorthand way to say that, okay? But it's the same thing. Now, you'll notice that it says the domains have to be, the domain of the new function has to be what's common to the other function. So remember that like if f is all real numbers and g is all real numbers, when you add them, their domain will still be all real numbers. But if f's domain was from 0 to infinity and g was all real numbers, then you want to look and see where do those overlap, because it won't be everywhere. It'll just be from 0 to infinity. So you need to include what limits you. Okay, so it's going to be where the two domains overlap. Now, let's take a look at some examples. So let's start by finding f plus g of x given these two functions. Well, I know this is f of x plus g of x. So I have x minus 5 plus x squared minus 1. I'm going to combine like terms and put them in order. So x squared comes first, x comes second, and then I have minus 5 and minus 1 give me minus 6. Now, the domain of f plus g of x. Well, f of x is a polynomial, so f of x's domain is negative infinity to infinity. G of x is also a polynomial, so its domain is also negative infinity to infinity. Therefore, when I add them together, the domain is still going to be negative infinity to infinity. Plus, when we look at what the function is, f plus g, we see another polynomial, which has, again, a domain of all real numbers. So let's take a look at something a little different. We're going to talk about the composition of a function. So this here, either version of this, okay, either on the left or the right, reads f of g of x. Okay, it doesn't read fog. Okay, it's meaning that you're plugging x into g, and then you plug what you get from that into f. So if we were to look at my penguins here, you plug x into g, and then you plug g of x into f. Okay, so you work from the inside out. Okay, so again, you plugged in the small penguin into the medium penguin, and then you plug them together into the big penguin. Okay, composite functions. Now, the domain of the composite function, f of g, is the set of all x, so that, first of all, x can be plugged into g. Okay, so that's required. But you also need to make sure that any x you plug into g lets you plug g into f. So keep in mind that you're not just looking at what you can plug into here, okay, but you're also saying, okay, which little penguin lets me plug my middle penguin into the big penguin, okay? So when you're looking at your nesting dolls, you have to think about the x values that affect g and the x values that affect f. So let's take a look at how to find a composite function. So in this case, I want to find f of g of x, which is really saying, you know, f of g of x. Okay, so g of x is going to get plugged into f of x. So what that means is everywhere there is an x in f of x, I'm going to replace it. I'm going to substitute in g of x. So in this case, it was originally 5x plus 6. I'm going to have 5 times something plus 6. In this case, the something is 2x squared minus x minus 1. Now, once you've substituted in, you just simplify, which means in this case I'm going to distribute. and I'm going to combine like terms. And that is f of g of x. Ta-da! All right, so let's do another composite function. So note that we are still finding f of g of x, but our f and our g have changed. So now I'm going to take my f of x, which was 4 over x plus 2, but instead of x, I'm going to plug in g. Now, remember what g is. G is 1 over x. So again, pay attention to what we did here. Since we plugged in g instead of x, we plug 1 over x in, because that is what g of x is. Okay, so that's where this came from. Now, we still need to simplify this. We don't like fractions in fractions. Anytime that happens, you want to make sure that you combine things that are fractions in one part. So in this case, in the denominator, I have 1 over x plus 2. So I'm going to first of all recognize that 2 has a denominator of 1. So now my common denominator between those two things is x. So I'm going to have to multiply by x on top and bottom for that piece. Now that gives me 4 over 1 plus 2x over x. But keep, change, flip, or dividing by a fraction is the same thing as multiplying by its reciprocal, turns into this. And then I get 4x over 1 plus 2x. All right. Now, that is the function f of g of x. Now, a couple of things here are to recognize that it's also going to want us to find the domain in a moment here. Okay. See? Wants us to find the domain. In order to do that, you have to recognize a couple things. Well, first of all, I'm going to copy over what we got. We got 4x over 1 plus 2x. Okay, so first of all, note that we said x's can't be anything that caused problems in g in the first place. So x cannot be 0 based off of our g. Okay. We also need to find all x values that cause a problem when you plug a g into f. Okay, so now I need to look and see, okay, I know that g, when I plug it in here, cannot cause a 0. Okay, so 1 over x plus 2 can't equal 0 either. Okay, and if you're wondering where the 1 over x plus 2 came from once we plugged in, right here, once we plugged g in, that was the denominator, okay? So we know 1 over x can't be negative 2. 1 can't equal negative 2x, and x can't equal negative 1/2. And you'll notice that if you found what x couldn't be looking at this function over here, what we got for f of g of x, you would also get that x couldn't be negative 1/2. So that's valid both ways, okay? So x can't be 0 or negative 1/2. Those are the two limitations on the domain. So recap, the 0 causes the problem in g, okay? And negative 1/2 causes the problem in f of g of x. Notice that if something causes a problem in either of those, then that's a limitation on the domain. However, if you wanted to tell me that x couldn't be negative 2 because that causes a problem in the f domain, that's not valid. Because when we go back and look at our list of things that cause problems with composite functions, it's the smallest penguin and the medium penguin. So the big penguin is not affected by limitations on the domain directly. So let's see if we can write a function as a composition. So I want you to look at this and tell me what could f of x equal and what could g of x equal, so that if h of x was f of g of x, then f of x and g of x would create that. So remember here, Olga here is the penguin plugged in, and Nestor here is the outside penguin. Okay, Nestor is f of x. Okay, yes, by the way, they do have names. Okay, f of x is the outside function, which means in this case the outside thing. Okay, but that's the thing on the outside. So f of x has to be a square root, but because it's f of x, what we need to plug into it is x, square root of x. You can't just write square root with nothing in it, okay? And then my g of x is the inside penguin. So you can see that what's under the square root or inside the square root is x squared plus 5. So if I were to plug x squared plus 5 into square root of x, hopefully you can see that I would get square root of x squared plus 5. Now, some of these types of questions will have more than one answer and some will only have one. In this case, I'd say there's really only one obvious answer, okay? This is a simple answer. You could probably come up with some complicated ways to get f of g of x here. However, try to go with the simplest one. Ooh, excuse me. All right, so let's go ahead and jump into some practice problems. Try to find the domain of this function, both in x does not equal format and in interval format. So remember, we have to start by factoring out the denominator. Ask myself what two numbers multiply to 18 and add to 11. Well, I think 9 and 2 fit that bill. So I have x plus 9 and x plus 2. Now, I know that my problem is that I can't have anything that makes it 0 in the denominator. Well, negative 9 causes a problem here. Negative 2 causes a problem here. So x cannot equal negative 9 or negative 2. Notice that I am writing them in order from least to greatest, or from left to right, just because it makes it easier when I'm looking at my domain to say, okay, I see everything up to negative 9, union everything between negative 9 and negative 2, union negative 2 to infinity. I cannot switch negative 9 to negative 2 in my interval because it wouldn't make sense to go to negative 2, back to negative 9, and then past negative 2. That wouldn't make any sense. But if I do up to negative 9, up to negative 2, past negative 2, that would follow. Okay, so again, it's important here that you make sure your numbers are in the correct order. If you know that what's under a square root cannot be negative, you can find the domain of a radical function. Try that for me. So, not negative means it can't be 0. And, it can be 0. I'm recording this earlier in the morning, I'm sorry. It can be 0, and it can be positive. So, just to recap, it cannot be negative, it can be 0, it can be positive. What is under the square root? Okay, now, possible for it to be 0 and positive means I take what is under the square root, 32 minus 4x in this case, and I set it greater than or equal to 0. Okay, this would cover all numbers that are not negative. So I want to solve this. Now, if I were to subtract 32 from both sides and divide by -4. When I divide by a negative in an inequality, it flips the inequality sign. So even though it was greater than or equal before, it is now less than or equal to 8. So my domain in interval notation is -infinity to 8 with a bracket. -infinity to 8 with a bracket. Notice that the bracket is only on the 8 because it's or equal to 8. Okay. It can't be on -infinity because you can't include infinity or -infinity. Now, if you chose to solve this a little differently, let's say when you did 32 minus 4x is greater than or equal to 0, you added 4x to both sides and then divided by 4, you'd have gotten 8 is greater than or equal to x. Notice that these are the same thing, but one requires you to divide by a negative and remember to flip the inequality sign, and the other did not. So it's up to you which way you would do it, but recognize that if you forgot to flip the inequality sign, you may want to move the x's over so that they're always positive so that you don't have to divide by a negative, and just get in that habit. All right, so I want you to find f plus g, f minus g, f times g, and f over g. And for each and every one, I want you to find the domain. Hopefully you found all of them. F plus g of x is 4x squared plus 22x minus 42 plus x plus 7. So that's 4x squared plus 23x minus 35. Okay, and its domain is -infinity to infinity because it's still a polynomial, just like f and g were. Now, f minus g of x is 4x squared plus 22x minus 42 minus, and don't forget your parentheses here, they're super important, x plus 7. They're super important because you're distributing that negative. So I distribute it and I get minus x minus 7. That gives me 4x squared plus 21x minus 49. And this domain is also -infinity to infinity because we started with a polynomial, two polynomials, and we ended with polynomials. If you haven't yet tried f times g and f divided by g, give them a go. So, f times g of x means I'm going to have 4x squared plus 22x minus 42 times x plus 7. Now, this does mean that I'm going to need to distribute. I'm going to distribute the x and the 7 because it's just going to make it a little prettier, okay? So I start by distributing the x. And I'll go ahead and switch colors here. I think that's 154x. And 294. I'm going to write that one out. 7 times 2 is 14. 7 times 8. 7 times 4 is 28. Plus 1 is 29. Yeah, 294. So minus 294. And then I combine like terms. And that gives me 4x cubed plus 50x squared plus 112x minus 294. Ta-da! Now, its domain is also all real numbers because we start with a polynomial, we start with another polynomial, and we ended with a polynomial. Is it always going to be -infinity to infinity? No. Especially if you've already tried f over g, you know its domain will be limited. So go ahead and try writing that out if you haven't already. So f over g of x is, well, 4x squared plus 22x minus 42 over x plus 7. Now, two things. One, you should go ahead and find the domain now. It's negative infinity to negative 7, union negative 7 to infinity. The other thing is you should check and see if this is simplifiable. If it's simplifiable, I do expect you to simplify. Now, a couple things. One, there's a GCF on the top, so I recommend pulling that out. In this case, it's 2. Then you want to use the asterisk to factor the numerator. Go ahead and try that. So drawing the asterisk up in the upper corner here. So this is negative 42 on top, 11 on the bottom, 2 on the top sides. I need to see if there are any two numbers that multiply to negative 42 and add to 11. And the answer is yes, there are. They are 14 and negative 3. Now 2 over 14 does simplify to 1 over 7. So I can now write this as 2 parentheses x plus 7 parentheses 2x minus 3 over x plus 7. You notice my x plus 7's cancel, so hopefully I am not covering this up with my face yet. I have 2 times 2x minus 3, which is really 4x minus 6. Okay, so f divided by g of x is 4x minus 6. But it still has the domain restriction at negative 7, okay? It still has the domain restriction negative 7 because if I were to plug negative 7 into this version of it, I would be dividing by 0, which is not good, okay? So just keep in mind that even if it does simplify, look at its original format before the simplification to find what your domain is. Now, let's find composite functions. So what I'm going to do is I'm going to let you do f of g of x, and then we'll come back and do g of f of x together. So y'all try and find f of g of x. So for f of g of x, okay, which I write like this, I have 5 times x minus 4, and I'm going to plug g into that. So I have 2x squared minus 2. I can distribute and combine like terms, and I get 10x squared minus 6, sorry, 14. That's a 14. I can read my own handwriting. Really, I can't. All right, so that one was pretty straightforward. Right? And again, notice since g was the inside one, you plugged g into f. However, if I were to do g of f of x, okay, which is part b, that means everywhere there's an x in the g function, I'm going to have to replace it with f of x. So notice, again, the inside function goes inside everywhere there was an x. Okay, so now we're plugging 5x minus 4 in to this function. So like that. Now, remember, squaring 5x minus 4 does not give you 25x squared plus 16. It does not. It doesn't give you 25x squared minus 16. It doesn't do that either. You have to write it out twice. So I have 2 times 5x minus 4 times 5x minus 4 minus 2. I can FOIL out 5x minus 4. But I want you to try it first. Hopefully you have done that. So when we FOILed it out, we should have gotten 25x squared. And then when we combined like terms, we would have gone minus 40x plus 16. We still have our minus 2. Go ahead and distribute and combine like terms. When you distribute, you should get 50x squared minus 80x plus 32 minus 2, which means that our final answer is 50x squared minus 80x plus 30. So again, remember that f of g of x is not necessarily the same thing as g of f of x. It does happen occasionally where they match, but it won't happen very often. All right, so let's take a look at this and see if we can't simplify some things. So f plus g of negative 2. Reminder that what I'm saying here is f of negative 2 plus g of negative 2. Looking at our graph, what is f of negative 2? Well, our function f is the blue one. Okay, you see it's labeled down here. And x equals negative 2 gives me a y value of 1. So f of negative 2 is 1. What's g of negative 2? Hopefully you see that g of negative 2 is 5. So f plus g of negative 2 is 1 plus 5 is 6. You tried finding f times g of 0. So just the same way, we need to find f of 0, which is 0. We need to find g of 0, which is 4. And in this case, it's multiplication, and 0 times 4 is just 0. All right, let's take a look at a composite function version of the same thing. Okay, f of g of negative 2. Notice that this is saying f of g of negative 2. So the first thing you want to do is find g of negative 2. Remember, you're always being able to work from the inside out. Now, g of negative 2. Okay, so I'm going to go to negative 2. And g, it looks like, is the red one. So I go down. That's g of negative 2 right there. So I can now say this is f of, well, negative 2 gives me negative 1. Okay, so again, notice that since g of negative 2 is negative 1, I can replace it with the value negative 1. Now, it wants to know what is f of negative 1. And since, oh my goodness, didn't mean to erase that. Okay, negative 1 is right here. I go up, and I say, okay, negative 1. When I plug that into f, I get 8. So remember, work inside to outside. Inside to outside. Plug negative 2 into g, then take what you get and plug it into f. But do show your work this way. Notice that I have to write the f of. I can't just write g of negative 2 equals f of negative 1. You have to have this f on the outside. Don't forget to write it. Awesome, you made it through combinations and composites of functions.